the logarithm and the exponential, so that's what we're going to do here. Remember, you always start at the base. So the base of the log is the base of the exponential. So it'd be 3 to the second power equals the 4x minus 7. So 3 to the second is 9. You add your 7. Divide and you get x is 4. Now, one thing is new on this. You need to always check your answers. In a logarithm, the base and the argument have to be positive. If I plug a 4 in here, do I get a positive argument? Yes, that's what you need to verify. If I had gotten like 0, when I plug a 0 in here, it wouldn't work, so you would have to tell me no solution. So when you plug your x in, it gives you a negative argument, you have to say no solution. Otherwise, just verify that it is a positive base and positive argument. Alright. Is that okay with everyone? So let's look at B. We change this to exponential. That means x to the second power is equal to 64. How do you get rid of a square? Square root. If you add a square root, what else do you need? So I get x to equal positive and negative 8. Is that alright? Any problems with that answer? Look at what x is. X is the base. Can you have a negative base? No. So we got negative 8 for an answer, but we check it, and what that tells us is x equals 8 is our final answer. You may get more than one answer. Sometimes they might both work. Sometimes only one of them does. Or sometimes neither one does. So always verify that. Is that okay with everyone? Just try some more. So how would I write this? Okay. What do you want to do with that? What is the negative x going to do? So that says 1 over x squared equals 16 over 9. What do we do with that? Cross multiply. Divide by 16. How do you get rid of a square? With that we do plus and minus. Square root of 9 is 3, square root of 16 is 4. Now check. Are both of those possible answers? No, because the x was the base has to be positive. So positive 3/4 is the only answer that works. Alright, I want you guys to do B and C, please. So the first one, you get 16 to the 3/4 equals x, which gives you 8. Plug it in, 8 is positive, so that's fine. Last one. You get 36 to the x power equals the square root of 6. How do you solve that? You could square each side if you want to get rid of the radical. That would work. So power to the power you multiply, so you get 36 to the 2x equals 6. Then what? Same base. 36 is 6 squared. That means 6 to the 4x equals 6 to the first. So drop your base, and x is 1/4. Any questions? Alright, let's try one more.
This seems really easy with just the twist.
I don't know what you're talking about.
With a big Y. Did you really start recording?
Yeah.
I just can't see the little lines.
I know, I've got my rectangle big enough. Alright, what would I do here? Two cubed equals 2x plus 1. 2 cubed is 8. Subtract your...
Couldn't you just square put cube root with this?
You could, but I wouldn't want to put this under a radical. I just evaluated 2 to the 3rd power. So then you subtract your 1, divide by 2, and you get 7/2. Do a quick check. We know that our argument has to be positive, so if we put a 7/2 in, we're going to get a positive number. But it is possible that you might get an x value that when you put it in gives you a negative argument. And remember, we cannot have that. Alright, are we good with solving these equations? Change them to exponential form, then they're like what we have in solved. The next piece we have are we're going to talk about some properties of logarithms. So I'm going to put the properties up here, let you write them down, and then I'll talk about them. Okay. You don't necessarily have to write this line down. It just tells you that everything's positive because that's the rule for logarithm. What you really need to get down are the product, quotient, and power properties. The product property says if you have the log of things being multiplied together, you can do the log of each one individually and add them. If you have the log of things being divided, you can do the logs individually and subtract. The one that's on the denominator gets the minus sign. If you have the log of something to a power, you can bring that power down in front as a coefficient. The last two things here, you don't necessarily have to remember as rules. You might, but if not, they're fairly easy to figure out. Log base a of 1. That's just saying a to what power equals 1? 0. Log base a of a to what power equals a? 1. So those are properties that can be useful to remember, but it doesn't take a lot of effort to think through it if you were to forget that it's a rule. Okay? So what we're going to do is just practice using some of these properties. We're going to start out with fairly basic ones today. Tomorrow we'll get into some of the more complicated expressions. But let's say I asked you to evaluate this. Log base 8 of 2 plus log base 8 of 4. We did it at the end of algebra 2. Log base 8 of 2. Do you know off the top of your head 8 to what power equals 2? Anybody jump? Okay, so if you don't know, how else could we evaluate it? We can set it equal to x and work the equation. Now, the issue is, if you do that, we always want to change it to exponential form. But you can't write it as exponential form unless you just have one logarithm over here. How could I make that one logarithm? Multiply. If you have a log of two things added, then you can put them back together by multiplying. So this would be log base 8 of 2 times 4 for log base 8 of 8. Once you get one logarithm, you can evaluate it. If you need to, write it in exponential form. 8 to the x equals 8. So x is. So separately we couldn't solve them, but once we combined it, we were able to. B, these logs are subtracted. So how would I combine those? So this is log base 6 of 18 divided by 3. 18 divided by 3 is 6. Log base 6 of 6 is 1. Is that okay, everybody? 2 more properties that we need to get down. I'll let you write them and then I'll. Okay. Remember we talked about the exponential and logarithm or inverses of one another? What that means is if you do both operations, the exponential and the log, they essentially cancel one another out. So this one maybe doesn't seem as obvious as the second one. The justification behind them, you don't necessarily have to write this down. If you just remember, if you have the base of the exponential and the base of the log are the same, they can drop. This one, if you were to write it in logarithmic form, you would have log. The base of the log is the base of the exponential, so log base A, go across the equal sign of m. And if you keep going, that equals the log base A of m. So that's why this turns into just an m. If you have that logarithm as the exponent, in order to make this a true statement, those two cancel and just leave you with an m. The second one, you could even think about using properties of logs. If I just asked you to simplify log base A of A to the r, properties of logs, exponents come down. What's log base A of A? 1. So that's r times 1, which is r. So that one's a little more obvious. But again, that's just the justification to kind of explain why they're true. You just need to know their inverses, so if you have both, they cancel one another. So let's look at a problem. If I said x equals 3 to the log base 3 of 8 power, what happens? Yeah, the 3 and the log base 3 drops, so you just have x equals 8. Okay, second one. Let's rewrite this. If I told you to evaluate this, log base 4 of the cube root of 16, that's a little difficult. But a cube root is what kind of power? So what? 1/3. How could you break down 16? For the second. Okay, so properties of exponents, this would become 4 to the 2/3. Now do you know what x equals? 2/3. So log base 4 and 4 would cancel one another. And you get 2/3 for your answer. Last problem of the day. I just want to practice using those properties to rewrite some expressions, and this is where we will pick up tomorrow. So if I ask you to use the properties of logs here, how would you rewrite log base 7 of 8 times 6? You need to make sure you write the log base 7 each time. Don't forget the base. If you don't have a base written, it's assumed to be 10, which is different than a base of 7. So you have to write the log each time. B, how would we rewrite that one? They're divided, so you subtract. Make sure when you're writing these also that your base is a subscript, so I can tell the difference between your base and the argument. C. A cube root is like what kind of power? 1/3. Where do exponents go? So it would be a 1/3 log base 2 of 9. I'm going to skip D because it's pretty much the same as the one we just did. I'm going to give you a different one to finish. Let's simplify this a bit. A square root is like what power? 1/2. So you would have all of this to the 1/2 power. If I just worked on simplifying this expression as it's written, you would take the 1/2 to each. So 3 times 1/2 would be 3/2. 2 times 1/2 is 1. 4 times 1/2 is 2. Now if I tell you to break this apart, let's start on the top. The r and the s are multiplied together, so what are you going to do with their logs? Add them. The 3/2 would go down in front, so it's 3/2 log base a of r plus log base a of s minus, this is a t squared, so the 2 would come down, log base a of t. This is where we're going to pick up tomorrow with using those properties on some more complicated expressions. Are there any questions over what we've done today? So, I don't have a very big assignment for you. I'm giving you some time to work on it right now. I think it's only like 9 problems.